Hello and welcome to the Deep Dive. Now before we jump in, if you're looking for the absolute best resources for Cambridge A&O level computer science, you really should head over to seeuswithzach.com. Seriously, it's the top spot. And while you're there, check out AskZ, that's our AI chat assistant teacher. Super helpful for basically any subject, any language. I'm AskZ, and with me is the AI teaching assistant.
Hello, everyone.
And we both assist Sir Zafar Ali Khan Zach, as many of you know him. Today, we're doing a real deep dive into a specific computer science topic. We're going to, leave no stone unturned, just like Zach would want.
That's right. And our focus today, it's squarely on nailing the Cambridge International AS&E level computer science paper. That's 961C, paper 2. You know, the one, the 2-hour, 75-mark written paper?
The big problem-solving and programming one.
Exactly, using pseudocode. And yeah, sources like Mr. Benassi confirm it's a full 2 hours, so time pressure is definitely a factor.
Absolutely. So our plan here is to really dig into past paper trends, talk about some, educated predictions, and give you solid strategies for doing well in paper 2. We should also mention Cambridge has that new syllabus starting in 2025, right?
Yeah, that's important.
There are updated specimen papers out there on the Cambridge site. The core skills are pretty much the same, but there might be format tweaks. We'll definitely point those out as we go. Zach always stressed staying current with the syllabus.
And think of this deep dive as your shortcut, really. We're trying to get you up to speed quickly on how best to prep for paper 2. We've done the groundwork, look for the patterns, the winning strategies.
Save you time and effort, which, let's be honest, Zach was always a big fan of efficiency.
Definitely.
Okay, let's dive in then. Past paper analysis first. We're looking at 2023, 2024, maybe peek at the 2025 sample stuff too. The aim is to spot those key themes, the things that keep coming back. And paper 2 is quite focused, isn't it? Syllabus sections 9 to 12.
It is. Very defined. And because of that, yes, certain topics just tend to repeat. Take data structures, for example. It's almost a guarantee you'll see questions on stacks, queues, records, maybe arrays.
Right, like those diagram questions.
Exactly, like showing a stack and asking you to explain PUSH or POP, not just say it adds or removes, but, what actually happens. Or I remember seeing one May-June 2023, paper 22, I think it had a circular queue.
Ah, the pointers.
Yes, you had to explain how the front and rear pointers update after, say, an unqueue or duck queue, step by step, including the wraparound logic.
That's not just theory, is it? They want practical application, declaring arrays, using records.
For sure. There was one paper with a 1D array of records for stock items.
Right.
You had to write pseudocode to define the record structure, first fields, data types.
Okay.
And then write the actual line of pseudocode to, say, update the price field of a specific item in that array.
So, requires careful indexing, getting the field right.
Precisely.
So what's the big takeaway for listeners from looking at these past questions?
Well, it tells you, loud and clear, you need to be comfortable declaring and using arrays, maybe even 2D ones and records, defining them, accessing fields. And you really need to understand stacks and queues inside out.
Explaining the operation.
PUSH, POP, on queue, dequeue, yeah. And how circular queues work, maybe even priority queues if they're in the current spec. And beyond just explaining, you might need to write pseudocode to modify them, like implement a stack that has a size limit or something.
It all ties back to that data types and structures part of the syllabus.
Directly. It's fundamental. Zach always hammered this home. Get these basics solid, and the harder stuff becomes much more manageable.
Makes sense. Okay, let's shift gears to algorithm design and actually writing the pseudocode.
Yeah.
Seems like every single paper 2 asks you to do this, right? But the difficulty can vary quite a bit.
Oh, definitely. You get some that are relatively straightforward. Like, there was a function in June 2023, getNum. It just needed to count how many times a character appeared in a string.
So basic loops, comparisons.
Pretty much. Testing fundamental control structures and string handling. But then you get the more challenging ones. Remember the efficient bubble sort from May-June 2021?
Oh yes, efficient being the key word there.
Exactly. You couldn't just write a standard bubble sort. You needed that optimization, the flag, to check for swaps and exit early if the list is sorted.
And that carries significant marks, I bet.
It did. Reflects the complexity. It's more than just reciting an algorithm.
And we see other types too, right? Password validation seems popular.
Very. Like in May-June 2022. You get rules, minimum length, character types, and you have to translate that logic into pseudocode conditions.
Or file handling tasks, like reading the last few lines of a file.
Yeah, that was in the same paper, May-June 2022. Needs understanding of opening files, maybe moving pointers, storing lines in an array or buffer.
And formatted output comes up too sometimes, like tables or reports.
It does. Generating specific layouts, aligning columns, requires careful use of output commands in pseudocode. It really shows the breadth of problem solving they test.
Zach definitely believed in throwing varied problems at students to build those all-round skills.
So the underlying pattern here is, well, Cambridge consistently tests your ability to create algorithms from scratch, or maybe complete or fix existing ones. And the tasks cover string handling, sorting, searching, file I/O, common stuff.
So the advice is,
Practice. Practice writing pseudocode for lots of different scenarios. Look at past papers, you'll see these algorithm types recycle, just in new contexts. Mastering those core patterns and expressing them fluently in Cambridge pseudocode, that's absolutely key. It's that practical problem-solving Zach always pushed for.
okay, now let's talk about the pseudocode itself. It's not just about making something look like code, is it? They're quite specific.
Oh, absolutely not. You have to use the features exactly as defined in the syllabus insert. Examiners look closely at this, like using the built-in functions they provide. String functions, date functions, they appear often.
So things like MID for substrings or concatenation.
Precisely. Or maybe date calculations, finding the difference between dates, formatting them. Using the built-in functions for these is expected. You don't reinvent the wheel.
And if you don't use them, if you try to write it all yourself.
You lose marks, sometimes easy marks. The June 2023 examiner report specifically mentions students missing marks because they didn't use the provided date functions.
Wow. Even if they got the logic right otherwise.
Potentially, yes, because the instruction is often implicit. Use the tools provided. It highlights how vital it is to know that insert document inside out. Same goes for loop constructs for, while, repeat until.
Knowing when to use which one.
Exactly. There was even a case in May-June 2022 where converting a while to a for might have been appropriate, showing you understand the difference.
So that reference sheet is crucial.
Absolutely. Zach always called it invaluable. A cheat sheet in a way. Use it properly, it saves time and gets you marks for clarity and correctness. Knowing the tools is part of the skill.
But paper 2 isn't all about writing code, right? There are those conceptual questions too.
That's right. A good chunk of marks often comes from short answer questions about the theory behind the code, like parameter passing. You might see some code with procedures and functions.
And then have to explain pass by value versus pass by reference.
Exactly. How each one affects the original variable. The specimen paper even had a table asking for the differences, like how pass by reference lets the procedure change the original value, and questions about good program structure come up too.
Like, why use procedures? Local variables.
Yeah, the benefits for modularity, readability, maintenance. Zach always emphasized writing good code, not just code that worked.
Okay, and what about software development and testing? That seems like another key area for these conceptual questions.
Definitely. You could be asked to identify testing types, like if a developer tests code units knowing the internal logic.
That's white box testing.
Right. Or they might ask you to differentiate between, say, unit testing and integration testing, or black box versus white box.
And debugging tools.
Yes. The June 2023 paper had a question. After showing some buggy code, asking how IDE features like breakpoints or watch windows help find the error. So yeah, understanding parameters, scope, algorithm correctness, testing techniques, debugging, it's all vital. Zach really believed strong theory underpins practical skill.
So if we zoom out and look at paper 2 overall, what's the big picture?
Well, based on everything we've seen, it's a balanced paper. Roughly half the marks are for writing or modifying pseudocode. The other half is explaining concepts related to code or general principles.
And the repetition is key.
It really is. These core themes, data structures, algorithms, concepts, they tend to reappear. So mastering them gives you a massive advantage. You start seeing the patterns. Examiner reports even say there are accessible marks in the pseudocode questions if you just follow the expected structures.
Which really reinforces Zach's idea. Learn from the past to succeed in the future.
Precisely.
Okay, great analysis of the past. Now for the slightly trickier part, predictions. Based on these trends, and maybe considering the new 2025 syllabus, what do you think we might see coming up?
Well, prediction is always a bit, speculative. But the patterns are strong clues. Take data structures again. We see stacks and queues often alternating.
So if stacks were big last time, maybe expect queues next.
It's a reasonable guess. Maybe tracing on queue a queue in a circular queue, or even writing the pseudocode for those operations. Or if queues were recent, perhaps stacks will return, using PUSHPOP to reverse a string, check for palindromes, that kind of thing.
What about linked lists?
Less common at AS level, but not impossible. But based on recent trends, I bet on seeing either a stack or a queue question. Key is understanding pointer index movement and handling overflow underflow. Zach always said, be ready for variations on the core ideas.
Makes sense. And what about algorithms? That's always a major feature.
Absolutely central. Okay, so bubble sort was tested efficiently in 2021. That might mean another sort or a search is due.
Like binary search, insertion sort.
Those are strong candidates, either writing the pseudocode from scratch or completing a partial one. Or if sorting's been done recently, maybe a search task. Binary search on names, perhaps tracing it.
And password validation keeps coming back.
It does. It's a favorite. Maybe this time, instead of just checking rules, you'd have to generate a random password meeting criteria.
Ooh, interesting twist.
Or maybe just more complex validation rules. The core skill remains string manipulation, loops, conditionals. Overall, I'd strongly anticipate at least one algorithm needing iteration and conditional logic. Applying for or while loops, maybe nested ifs?
Those fundamental patterns Zach always stressed.
Exactly. Mastering them is crucial.
What about records and files? They seem pretty consistently tested, too.
Yes, definitely part of the problem-solving syllabus section. Again, looking at rotation. If recent papers focused on file reading.
Then maybe file writing or processing is next.
Quite possibly. Or maybe the focus shifts to in-memory work with arrays of records. I'd say there's a strong chance of a question using an array of records, searching for records meeting criteria, similar to that stock item example.
Or maybe appending data to a text file.
Yeah, using open file for append, write file, close file. That's a practical skill they like to test. And be ready for multi-step problems. Read data, process it, output results.
That breakdown approach Zach advocated.
Exactly. Break down complex problems into smaller, manageable steps.
Okay, now, the new 2025 syllabus. Any big curveballs we should anticipate for Paper 2 specifically?
Well, the core focus should remain problem-solving with pseudocode. The syllabus does introduce some basic OOP ideas, methods, properties.
But that's more likely for A2, right?
Primarily, yes. A full-blown OOP question in AS Paper 2 seems unlikely right away. You might get a conceptual question touching on it, like asking about the benefits of using a class, maybe. But probably not writing OOP code yet.
So evolution, not revolution.
I think so. The new format, maybe the longer practical exam mentioned elsewhere, might mean Paper 2 could have slightly larger, more integrated problems. Maybe combining algorithm design and then asking how you test it, perhaps.
But still using the same fundamental building blocks.
Exactly. Loops, arrays, sorting, debugging, the core skills remain the same, just applied in potentially new ways.
And finally, those conceptual software development questions. What's likely there?
Expect at least one. High probability topics, types of testing unit, integration, alpha, beta, black box, white box, definitions, purpose, identifying them in scenarios.
Their types too. Runtime, syntax, logic.
Yes, and debugging tools. How IDE features like step through or variable watch help. A future question might ask you to identify black box testing based on user interaction without code knowledge.
Or maybe compare dry runs versus using a debugger.
Plausible. Since interpreter versus compiler was touched on recently, maybe the next focus shifts to testing stages, or validation versus verification.
So don't ignore the wordy bits.
Definitely not. They can be easy marks if you know the definitions. Defining white box testing, explaining local versus global variables, these come up. Zach always reminded us the theory is just as important as the practical code.
Okay, so summing up the predictions.
We're expecting Paper 2 to cover array record processing, probably one algorithm to write from scratch, string or numeric, maybe a trickier algorithmic challenge, search logic, and definitely some theory questions on programming practices. And this isn't just guesswork, it's based on clear exam cycles and syllabus coverage.
But be flexible, right?
Always. If something unexpected pops up, you should still have the core tools from your learning to tackle it. A solid foundation is key.
Right. So we know what might be in the exam, but knowing it and doing well under pressure are different things. Let's talk strategy. How do you actually master this exam?
Yeah, strategy is huge. Having a plan makes a massive difference. First thing, soon as you get the paper, take maybe 2 minutes, scan everything.
Just read through it quickly.
Yeah, spot the big pseudocode questions, the 6-8 markers. Note the smaller ones too. Get a feel for the whole paper. This helps you mentally allocate time. Roughly 1.5 to 2 minutes per mark is a decent guide, so an 8-mark question. Plan for maybe 12, 16 minutes.
Avoids nasty surprises later on.
Exactly. You don't want to get bogged down early and find a huge question left at the end with no time.
Okay, so scan done. What next? Where do you start actually answering?
Go for the easy wins first. Identify the questions you feel confident about. Maybe it's a simple pseudocode bit using a function you know well, or a definition question.
Like, define call by value.
Perfect example. Nail those down quickly. Secure those marks. It builds confidence, gets you rolling. And it means even if you hit a wall later, you've already banked some points.
That's smart.
Oh,
Zach always said start with what you know.
it's solid advice.
Okay, easy points banked. Now you're tackling the bigger pseudocode questions. Any hard rules here?
Absolutely. Stick to the Cambridge pseudocode conventions rigidly. This isn't the place for Python or Java syntax. Use their keywords, capitalized, if, then, and def, for, while, etc.
Indentation matters too.
Critically. It shows the structure, helps avoid mistakes like missing an end day. The June 2023 Examiner report stressed using standard Cambridge pseudocode, not actual programming language syntax, and only use the functions and operators listed in the syllabus insert. Don't make things up or use library calls from other languages.
Stick to the rules. Make sense for fairness and clear marking.
Exactly. Even if your logic isn't perfect, clear, standard pseudocode might get partial credit where messy, non-standard code gets nothing.
Right. Now, for those really complex algorithms, the ones that make you think, is it best to just jump in and start coding?
I'd actually advise against that. It's tempting, but take a minute or two first. Plan it out.
Like a mini outline.
Yeah, even just scribbled notes in the margin. Loop through array, check condition. If true, do X. Update result, output result, something like that.
Helps clarify the structure before you write.
Massively. Helps ensure you cover all the essential components the mark scheme will look for, like for a search. Initialize flag, loop, compare, set flag return index. The exact loop type might matter less than getting all those logical steps in. Planning first avoids mistakes and ensures you don't miss crucial parts.
Good tip. What about trace tables? They can be a bit fiddly.
They can. The key is being systematic. Use the table format given or make your own clear one. Update variables step by step. Show you're working. Add extra columns if it helps you track things. Examiners see it.
And marks are often per row, right?
Often, yes. So even if you make a mistake, keep going based on your wrong value. You might still get marks for later correct steps based on that error. And use simple test data. Don't make it harder than it needs to be. Double-check the first and last loop iterations, especially off by one errors, are common.
Okay, and the big one, time management. How do you stop getting stuck?
You have to be disciplined. Stick to your time allocations per question as much as possible. If you're spending way too long on a low-mark question, it's probably better to make your best guess, leave it, and move on.
Get points elsewhere.
Exactly. Attempt all questions. It's better to have a decent attempt at everything than perfect answers for half the paper and blanks for the rest. If you're truly stuck on pseudocode, maybe write comments outlining your logic. Might get some method marks, potentially, but aim to give every question a proper go.
And make sure you use the resources they give you, like that pseudocode insert.
Absolutely. If the question says refer to the insert, that's a massive hint you need a function from it. Check it before you try coding something complex from scratch. And pay really close attention to command words. Write pseudocode means code. Describe or explain means English prose.
That all mix them up.
No. Examiners complain about this. Answer what's actually asked. State, give, explain, write pseudocode. They all require different types of answers.
Okay, and if you do finish with a few minutes spare, what's the best use of that time?
Go back and check key things. Did you close all your end-ifs, end-whiles, nexts? Easy mistakes to make under pressure. Do a quick sanity check on trace tables. Does the final output look reasonable given the input? Check variable names are consistent. Did you call it total here and sum there? Fix it.
Little things that can make a difference.
They really can. Clarity and consistency help.
That's all really practical, helpful advice. It really sounds like success is that blend of knowing the stuff and knowing how to play the exam game, so to speak.
It is. It's having the toolkit and knowing how to use each tool. When you see a Q question, you think, okay, practice this. Initialize pointers, loop, check conditions. It reduces panic, boosts efficiency. And remember, the mark schemes reward logical, clear approaches. Even a flawed attempt that shows good thinking can get marks. Use the standard pseudocode. Use the insert. Communicate your solution clearly. That's what examiners want to see. Zach always emphasized clear communication.
Okay, this has been incredibly useful, a real deep dive into paper 2. Let's quickly recap the main takeaways before we finish up.
Sure. So we saw that core themes repeat. Data structures like arrays, stacks, queues, fundamental algorithms like sorts and searches, key concepts like parameter passing and testing. We predicted future exams will likely continue focusing on array record processing, require writing at least one algorithm, maybe a sort or search, and include theory on programming practices like testing. And critically, we discussed exam strategy. Scan and plan time, grab easy marks first, stick rigidly to pseudocode rules, think before coding algorithms, be systematic with traces, manage your time, use the insert, answer the question asked, and double check if possible.
Brilliant summary. So for everyone listening and getting ready for paper 2, what are the absolute must-do action items?
Practice, practice, practice. Get recent past papers from the official Cambridge site. Do them under timed conditions. Then, and this is crucial, compare your answers meticulously to the mark schemes and read the examiner reports.
Why the reports?
They tell you common mistakes, what examiners liked, where students went wrong, invaluable feedback. It's the best way to fine-tune your technique. Zach always stressed learning from feedback.
And if they hit a roadblock, if they're stuck on a topic,
Don't just ignore it. Seek help. Use study guides, textbooks, especially Cambridge-endorsed ones. Check online forums like Ray Level or the student room carefully. Don't get lost. Or find video tutorials walking through problems. Ask teachers, ask classmates. If trace tables are your weakness, find specific tutorials on trace tables. Be proactive. Zach encouraged that.
absolutely. So, final thought for our listeners heading into this exam.
Remember that success comes from both knowledge and technique. You know the material, especially if you focus on those recurring themes we discussed. Now combine that with smart exam strategy planning, clear pseudocode, time management. Treat each problem like a puzzle you have the tools to solve. We really wish you the very best of luck with your 9618 Paper 2. Go show them your problem-solving skills. Apply these insights, and you really can unlock the secrets of this exam, something Zach was always so passionate about helping students achieve.
He really was. And remember, cswithzach.com and AskZ are always there for ongoing support and resources, keeping that spirit of dedication alive. Thanks for joining us on the Deep Dive.